Okay, let's see. Suppose that I don't want to see all of the things, but I only want to see some of the things. What am I going to do to the loop? If I don't want to see every motor, suppose that I only want to see the motors that have more than 10 hours on them. So that's an if statement that just surrounds this thing and then says if for some reason some motor got get hours past service, or how about is time for service, even better. So past time for service is true, then in case that thing that only print out some of them. And I guess we should make sure that at least one of the motors at some point has some extra time on it. So we'll do second motor add hours, and we need 35 hours. And run that one, and it'll print out there's just BB equal no longer. Okay. So that's still going through all of them, but only looking for certain ones, which in the business is known as a filter. Because it just eliminates certain ones and only shows some of the other ones. It filters out some and some. Okay. Another really common thing that you do with loops. What other options do we have? Another common question is, how many items have I got on the list? How many motors am I taking care of? Is talk to whoever's holding on to all of the motors and ask them how many items do you have, and then we can print that out. Case it's going to say two. So that if statement didn't change the list, so it's still going to say 2 items on there. Let's see, what else can we do? Suppose that you wanted to get a certain one. Retrieve it off the list. So notice that in this thing, we've basically forgotten this variable no longer refers to the one that we put on the list first. And so now I just want to bring the first one back off the list in order to see it. One way that you can retrieve them is by position. So you can talk to the list, all motors, and you can ask it a question, which in this case is get, and you can say, get me the number 0 item off the list. If you ask it a question, you need to put the result someplace where you can hold on to it briefly. So we're going to put it into a variable. We call it first motor. We can type a variable, and we need to be specific about what we're getting back. That's important. And so now you can turn around and print out the motor. And see what it prints. What do you think it's going to print? This is something we did way back when, probably within the first week. If it prints out all of the values of a motor volt, which would be what we would expect. So the easy way of looking at this is that if we're mentioning the name first motor, the only piece of information that the compiler knows about, or that Java knows about at this point, is where the variable hides in memory. And so that's actually a memory address. Okay? So the default is to print out the memory address, which is sort of useless. So if you ask an object about itself, give me all your information, that's all it knows about itself. The only way that you make it smarter is to override that default function to give it to supply the information that you know about what's inside the object. So what's missing here is in the motor class we haven't written a toString. So we'll go back and we'll write a toString to add more information. It's overriding an existing toString that is printing out that address. So we're going to make our own fancier version. And the trick to this is typically make a string that contains nothing to start with, return the nothing, and then work your way back into the middle to figure out something better to return than nothing. So we'll take results and we'll add to it the serial number, so that shows you the variables that are at the top of the file. We'll add the serial number. And we'll add in probably add in all of them. So now you have a toString to do the work of formatting the information that you actually want to see. And then you go back to the driver now and you run it. I think that's some useful information. Okay. And I've said before that toString is just basically a debugging tool. Usually you're going to use it to dump out all of the information in your object because you're using it in a print statement. The variable name, I just want to see what this thing's got. Not usually intended for any purpose other than debugging. Okay, so we can now turn around and retrieve things by position. So we can get the number 0 item, get the number 1 item, get the number 2 item, and we can tell how many items are on the list. So now we could conceivably, instead of using the for each to retrieve things, we could go through and print them all out instead. Okay? And I'm going to show you a technique for writing loops which is completely backwards to the way you learned to do it before. Okay? As usual in Viper methodology. Okay? So what we've got here is a piece of code that does one of the items that we want to see. Okay? If you wanted to get it to do many of the items, then that number would have to change from 0 to 1 to 2 to 3 to 4 to 5. So I guess that's going to be a variable in order for them to change. Well, if that's going to be a variable and I wanted to go through all of them, I'll write a loop that goes through all of them. I equals 0, I is less than, how many items do I have on the list? We can ask the list, tell me how many items you have, and use that instead of us knowing. So that thing becomes I is less than all millions plus size, I plus plus, here's the loop, and then we say, this is all of the stuff that the loop needs to do. And then you hit source format, and it fixes it up all nice and neatly for you with the proper indentation. Okay? So here's one of the things about writing loops. We've been taught to write loops by saying, oh, I have to worry about the loop, and then I have to worry about the stuff inside it. Right? If you do that, what happens in the brain is you're now basically one level deeper inside something, and every time you're trying to write the guts of the loop, you're always looking up above at that loop thing and going, I wonder if that's right. Oh, let me write the guts. I wonder if that's right. Is that right? I wonder if that's right. right? And so you're 2 levels into the thing. In this technique, you write the, just let me get it to work for one of them, one specific one that you can understand, and then you generalize it afterwards to go, now I'll figure out how to go through all of it. And so when you're thinking about the how do I get the one of right, you write that stuff first, and then you throw the loop around it afterwards to make it more general. And if you're not used to writing them, and even if you are, it's a lot better technique to see if I can do one specific one and generalize it, and to try to keep the general loop and a whole bunch of stuff buried in a bunch of stuff figured out. Okay, so there's a quick technique for you. So now we'll give that a try and we'll see if it works. And now it's printing out all of the items in the line. Next thing about loops. It turns out that this for loop style of I equals 0, I is less than maximum number, I plus plus, is always going to be the same for you. Remember I said the other day that loops typically always go through all of the items? That bunch of gobbledygooks there still means the same thing, go through all of the items. Okay? And not only that, but if I ever see you writing I equals 1, if I ever see you writing I is less than or equal to, if I ever see you writing all modals dot size minus 1, then chances are it's wrong. Okay? Because it doesn't fit that 95% mold. So I'm going to, if I instantly look at your thing at your loop and it says anything other than that particular pattern, pretty good guess that there's something fishy about it. Probably not the general class. That's all there is to it. So anytime you want to go through all of them, what you're going to try and do is use this one if you can first. The reason for using that one first is that it's possible to make more mistakes with this one. If you accidentally put a 1 in there, then you skip the first one and do the second one instead. If you accidentally put a -1 at the end, then you're not doing the last one when you should be. And the most common cause of errors for people writing loops, particularly in C and C++, and this style of syntax, is that they forget the first one or the last one. Okay. Did any of you hear about the Google Calendar bug for Android phones late last year? It's about December. Okay? Someplace you could never have an appointment for December into your calendar. You have to be December just to sort of know. Right? Well, guess what? December is the last month of the year. And you can just bet that when somebody was going through the count of the number of items, they accidentally forgot to write their loop to include the last one because they stopped one too soon, and whatever it was that was going and doing their calendar thing now would never show the last month of the year. Okay? Even the big guys get caught with exactly that same problem. And so the reason for using this feature is that if you use the for each, there's no first, there's no last to think of. It promises to give you back every single one of the things that are there somewhere. You never have to worry about first and last. If you do care about position for some reason, then that one's a better choice if you actually want to worry about, for some reason, I need to know about the first or last. Now, one other piece of advice. If you're using this style of for loop, you will never write an if statement inside the loop that checks to see if it's the first or the last, which you see a lot of people do. If I, you'll see some code in here, if I equals 0, then I'm doing something special, da-da-da for the 0. The reason you're not going to do that is because if you really cared about the first, you would do something with the first before you got into the loop, and then you wouldn't have to worry about, do I have to ask every time? And if you wanted to do something with the last thing, you would wait until the loop completed, and then you would do your work out after the loop because you would know exactly where the last thing was. Okay? So as another general rule, you never need to set for the first or the last inside loops. It's probably at a step. What other things can I say about this? Probably good things. So, bottom line, you really need to use this one. Just memorize the pattern. It's basically always going to look I equals 0, I is less than maximum, I plus plus. Don't even have to keep plugging. Write that one. Probably good. Okay, so there's positional notation. Oh, that's what I was going to say. How can you see so many loops with that positional style of notation? Any reason why it appears you see so often? There's a lot of languages that have that. This style of notation comes from the way old original days of computers, when computers were first designed to do calculations for trajectories of rocket flight. Right? The people who were using computers in the beginning days were people who were mathematicians who wanted to do calculations fast. They typically did calculations on things like vectors, arrays of things was fairly normal. And so when they developed the syntax for doing things, the primary interest was in doing math type stuff, either one-dimensional or two-dimensional arrays. And so that idea of positions within an array was very important. And that style still sticks around forever because people are used to using it. This other style is a fairly new style. It's come out probably within the last 10 years or so. And it's a recognition that for the most part now, a lot of programmers aren't concerned with those mathy type things. What they're concerned about is going through a list of things and presenting them on the screen. Filling out a pick list of things to choose or do. And generally you want to display the entire list of things that are available, for instance motors, into a visual list so I can pick this one and say do something. Okay? And so now we've evolved from doing mostly mathy type stuff to just working with mostly a list of things where the position of the thing is usually associated with it. So that's why we're moving around. So we'll still use this one in some specific cases, but we'd much prefer to use the one that contains less possibilities of error at the top. Questions so far? Okay, so there's an example of a counted loop. Suppose that I wanted to retrieve something off of a list, usually to update it. In that case, if we use positional notation, which is by far the easiest, I'm going to want to say, oh, get me the number one item on the list. I happen to remember what it is, so I can update it. Okay? So we'll do that. What we'll do is we'll talk to all motors, and we'll say, hey, all motors, go get me something. And the option there is get something by position. So we have to specify a number. Okay? So I want to get the number one item off the list. If I'm asking it a question, it would be a good idea to put that back into a variable. The thing that I'm getting back is in order to update. And the thing that it is specifically a motor. So I'm going to retrieve the number one item off the list. And then I'm going to turn around and I'm going to talk to the motor that I've gotten. And I'm going to say, here's what I want you to do. Oh, you've gotten 20 more hours. Okay. So there's an update. Now I'll ask my quick question. Suppose I do that. What happens when motor number one enters? Still there or not still there? Still the same. So it was the equivalent of I retrieved somebody's phone number off the list, I phoned them to ask them to do something, I can throw away that piece of paper because their name or their phone number is still in my phone book. If I want to go get it later, it's perfectly fine to go get it later. If somebody else goes and talks to them later, gee, guess what? They've changed somehow. They're different than they were the last time because they've been updated. Some information has changed. Okay? So there's a sample update by position. Let's see. Let's do another common operation. Suppose that I want to did my own writing. I think you've done that already. Oh, okay. Suppose I want to copy the list. Somebody else wants a copy of my phone book. Oh no, actually I'll make it easier. Suppose that I want to make a new list, and the new list is only going to have a list of the motors that need service. Got my master list of all motors. Somebody comes along, whoever's mechanic is going to do the work, give me a list of all of the motors that need service so I can go do my job. That means that I want a new list of only motors. Ones that need service. And so I'm going to make a new array list that can only hold motors. So there's my new list. Now what? I don't know what the next step I'm going to do. I just want to hear if you would ask me to do it in English, what would you say? Go through all of the list that you've got, something like that. Okay? And the reason I'm making that point is that it's a good idea when you're writing code to have a sense of what you want to do first in general terms and that you can understand, and then go figure how do I translate the what in my head to how to write the code. Right? So that's go through all of them, the ones that I have already. So I'm going to steal the loop that says go through all of them, the best one to use. I'll put in the ending brace. Now that I'm going to go through all of them, what would you like to do? If it's past service, oh look, we've got something that says if it's past service, print it. So we'll steal the thing that says if it's past service, print it, and we'll say instead of worrying about whether or not we should print it, what we'll do is we'll take the need service list and we'll say, here, hold on to that motor. And then after we're done, if you want to see the motors that need service, you can say for motor thing in all motors in need service, go through all of the ones on the need service list, and then we might print them out. So I'll steal the printing out thing and copy it down here and paste in this thing now changes to the thing. Probably not the best name. So that make a new list that's going to hold the result, go through all of the motors looking for ones that match. If they're matched for whatever reason, add them on to the other list. Print them all out. What happens if I do this? service suddenly disappear? Yep. How many votes were they disappeared? How many votes were they still on? Now, people are getting smart. So they're still on the original list. There's still that idea phone book. I copied a bunch of phone numbers that I was interested in into a different phone book, handed that off to somebody. The original phone book still remains the same. So they're now independent phone books, each with a set of phone numbers, some of which are similar and some of which are different or nothing. The question was if the motor suddenly is serviced, do I need to go back to the original list and update it? The answer is that think of them as still phone numbers, right? And so if one person talks to you and says, hey, you've now had your shower, so there's the service. But then when the next person comes along and says, are you different than, have you had your shower yet? The answer used to be no, but now it's yes. Still on the original list because both of us have lists that are talking to the same person. So the answer is you don't have to go back and touch the original. The motor has changed by virtue of the fact that someone else was able to talk to it because it's on a different list, which is again perfectly normal expectation for how you would expect real life to work. It doesn't get removed from the new service list, but this is the guy does all of the stuff, services all of the motors, and then throws away his list because he doesn't need it. So you would, if you wanted to keep the list and shorten it, you would remove them maybe one by one as you were servicing. Yeah, there's lots of permutations to this game. You could get a motor. But yeah, in here what we would probably do, instead of printing it out, is what we would do is there would be something in here that says, service the motor, mark it as being serviced, remove it from the needs to be serviced list. Something like that, whatever it happens to be. So yeah, this is by no means inclusive. It's just trying to show you the sort of the general things that we would do, give you some sense of them. And I'm also trying to repeat the pattern, right? So you can see the pattern over and over again. Okay, let's try another one. Suppose that somebody said, give me a complete copy of the list. Because I need to go check all the motors for some reason to see what they've got in it. So I want a copy of the list so I can go over into the motor yard and examine the ones that you think you've got. How would I make a complete copy of the list, of the original list? Copy implies I need another list to keep the copy. So let's make a list of motors with the copy with new array list, which can only hold motors. So there's our copy of the list, and then we go through all of the motors that are on the current list. And our original list is all motors, and we would say copy dot add this motor, and that is what the copy. So basically the same thing we did before, only without a filter. Right? Instead of only adding some of them, we took out the if statement that we had, same example, and this time we added all of them. So now we've got a copy of all of them to do the list. Okay, let's just do this. Copy dot remove the 0 item, I'm done with it. So there's another thing that you can do with lists is say remove some item off of it. And again, this is by position. If I remove the 0 one, what do you think happens? Yeah, the number 1 becomes 0. Everybody slides down towards the front of the list. So 0 is now a different item than it was before. The size has shrunk, and so people still fit within the 0 through 5 number of items. Okay? Everybody shuffles down to fairly empty position towards the front. Okay, so that removes it from the copy. Is it still on the original all motors list? So if it were a phone book, I've got a phone book, you've got a copy of my phone book. If you remove a number from your phone book now that's independent, it doesn't affect mine at all. Your phone book is just now different. I've still got the same ones I had before. Okay, so that's a very common operation to do. I want to leave the original intact, and I want a copy of the list so that I can go do something, you know, make it smaller, change some things on it, add to it, remove it, update things, do whatever I want without affecting the original. Okay. Now, it turns out that copying is such a common operation that there's a shortcut for it. And the shortcut for it is that when you make your list, so there's motor, another copy, ArrayList that only can hold motors, it turns out that there's a second constructor available where you say, here's the list I want you to copy. So instead of the constructor having an empty parameter, it now has one parameter that says, oh, use this list to make the copy. Okay. The code that does that in the constructor is pretty much exactly what we wrote here. It just takes the all motors and goes and adds it onto the list when it makes it so that they're there to begin with. And it's really just a convenient shortcut that you don't have to keep writing loops to go through and do all the stuff. Okay? So there's the idea that list is providing a convenience method for you that just makes your life a lot easier rather than having to do it yourself. So there's two ways to copy a list. There's the hard way, there's the easy way. If you want to filter them, you have to do it yourself. There's no way of specifying, oh, only take this one, and only take some of them and make that copy. The question was, you know, which one is more common? It depends on your intention, you know. So sometimes you want the copy on purpose. So, you know, in a real life example, if Rita comes in and says, I want a list of all the students who are failing the class, then I don't want to destroy my original copy. Right? But if the operation is somebody comes in and says, oh, we're moving on to a new term, it's handling, remove all of the students who can no longer longer eligible for 139 because they flunked 132, then all of a sudden the list is going to be shortened. Right? We're not going to work on the copy, we're going to shorten the original. So the short answer is it depends on the problem of what you're trying to solve. Okay, how are we doing on list supply? Get the idea? Okay, and notice how often I've used for each, because most of the time I'm just concerned with all of them and not specifying. Okay, so now we've got this idea of updating things or retrieving things by position. The next issue we run across is instead of retrieving things by position, that's hardly the normal case, I want to retrieve things by their serial number instead. So how would I go about finding a specific item on the list by serial number. So this is, I guess you're going to have to go through all of them and see if I can find the right one. Okay? So go through all of them again is, let's write a loop. So we'll steal that one. And we'll look for a particular one. So that would be, let's get the serial number out one step at a time. Talk to this motor and say, tell me your serial number. And then if for some reason the serial number happens to match then we found the correct item. What do you want to do if you found the correct item? Suppose I wanted to just remember it so that I can do something with it. Put it into a variable so I can remember it. So you might try to do something like this. So there's a variable that will remember an existing mode. Notice there's no new there because I'm not making a new thing. I'm recording the phone number of the thing that's already there. Put it into a variable. Is that going to work or not? There's a couple of problems. First problem, how long is that motor going to live for? That motor was just made from this brace to this brace, and as soon as that brace disappears, it's going to be gone. Okay? So the life of a variable is what's its outer enclosing brace. So where do you want to actually declare that motor? It's got to come way out before loop. It needs to persist even after the for loop is done. Okay? And we'll set it to empty to start with to say we haven't found one. And now since it's going to persist, that goes away. And we'll come down here and we can now say if for some reason found motor is not empty, because you might have not found it, right, then we'll print out the found motor. That showed you something about the lifetime of variables and needing to make sure that the variable lasts for long enough that you can actually go and look at its value. So if you want it to be available after the loop, you normally put the variable before the loop and do it. In old style coding, it used to be that when you declared variables, you had to put them all at the top of the function. And you'll see programmers and programming languages that try to make you do that. In the Java world, what you try to do is you try to make the variable just before you're going to use it. Because that gives the people a sense of, oh, here's where I'm going to start to use it from here to here, rather than, oh, what's this thing doing up here that doesn't get used until way later. So the general rule is that variables are always declared to have the shortest lifetime possible, and then they go away. We don't want to keep them hanging around for less information is better. For that use. Okay. Now, the one thing I'll point out for next week is that doing this stuff inside the loop is not the Java way. That's the traditional programming way. And so in the next class on Monday, we'll find a better way to do that and a more object-oriented way to do it. Okay? So don't take that one as being the best one. And with that, we're done.